Section 10.3, composite functions. So topic of today is putting a function inside another function. So as an investigation, we're going to start with the function f of x, which is x squared plus x, and g of x, which is x minus 1. So a composition refers to taking the output of a function and making it the input of another function or the same function, and has the following notations. So the notation for a composition of functions is f of g of x or f g of x. So don't get that confused with yesterday we talked about this. So a closed dot represents the product. Open dot represents composition of functions. So they can be, it's a common that they're confused, okay? So composition of function takes us back to mainly math 10, and if I gave you the function of x plus x, and I asked you to find f at 2, this means we're substituting 2 into the function to find our result, which would be, 4 plus 2 would be 6. If I asked you to find f at a, that means I'm substituting a into my function for x. So my expression would change to an a squared plus a. So similar to that, except we're using expressions all the time, and we're substituting a function into another function. So if I ask you to find f at g of x, I'm taking the function of g of x and replacing it with the x value of in the function f. So starting off fairly simple, using arrow or mapping diagrams. So determine f of g of 2. So just like order of operations, we'd want to start from the inside of this composite function and work our way out. So I would first find g. Well, g at 2 would mean I'd substitute 2 in for my x value in the g function, which result in a value of 1. Now I want to find f. So now g at 2 gives us a value of 1. So this entire expression, g of 2, is now being replaced with the output of g of 2. So we're going to find f at 1. So f at 1 means I'm going to take a 1 squared. Now I'm using the function of f plus 1, which our final result would be 2. So f at g of 2 would give us a value of 2. Okay. What if we were to work with a set of ordered pairs? So given the function f of x has 1, 2, 3, 4, 5 ordered pairs, g of x also has 1, 2, 3, 4, 5, 6 ordered pairs. Determine f2. So again, g of 2, I'm going to look at my function of g. I'm going to find the x coordinate, which is here. So g of 2 gives me a y value of, I'm now going to take that y value and replace it with the x coordinate of f. So f at 1 would result in 2. So f at g of 2, my answer would be 2. Okay. F at g of 3. So I'm first going to find g at 3, which would be a 2. So now I want to find f. So g of 3 is now being replaced with 2. So f at 2, which would equate to 5. G of f of 4. So I'm going to find f at 4, which is 20. So technically I'm finding g at 20, which is not on here. So, but you should learn here, for every x value that we see, my y value is 1 less than my x value. So if my x value is 20, then my y value at g at 20 should be 19. G at f of 2. So I'm going to look up the x coordinate of 2 on here, which is 5. So now I'm going to find g of 5. Well, g of 5 would give me a value of 4. So my answer would be 4. G of 1 is 0. So now I'm going to find g at 0. So I'm inserting the function of g into itself. So g of 0 would be negative 1. Okay? So that's the whole idea, is you always want to work from the inside out. Okay? If f of x is equal to 4x and g of x is equal to x plus 6 and h of x is equal to x squared, determine f of g at 3. So I'm first going to find g at 3 would be 3 plus 6, which is 9. Now I'm going to find f at 9. It would be 4 times 9, which is, my result would be 36. G of h of, so recognize this is just a different notation. What this is meaning is g of h at negative 2. So every time I see this notation, I always rewrite it like this to remind myself this is composition of functions, not multiplying. So I'm going to find h at negative 2, which would be negative 2 squared, which would give me 4. Now I'm going to find g at 4. Well, g at 4, I'd substitute 4 into my g function, which would give me 10. My answer is 10. Of h of 2. So again, this means I'm substituting the function h into itself. So I'm going to find h at 2, which is 2 squared, which is 4. Now I'm going to substitute that back into h again. So my answer would be 16. Okay. So we've worked, all of the questions we've done so far is this x value has been an actual value and we've evaluated. Now we're just going to work in general, the general expression. So first thing, g of f at 0. Okay, well, I'm going to find g at f of 0. Okay, well, f at 0 would be 0 minus 1, would be the square root of negative 1, which doesn't exist. So f at 0 does not exist. Therefore, this composite function does not exist. Okay, so it has to work with the domain of the function. Here, just in general, this would mean g of f of x. So I'm going to take f of x and replace it with my x coordinate in g of x. So I'm taking the function f of x, which is root x plus 1. So f of x is root x minus 1. I'm going to replace that in for the x value in g of x. So g of f of x would equal, I'm going to replace x with a root x minus 1, and then I got to square that whole function. So g of f of x, these operations just cancel each other out, is simply just x minus 1. Okay? All right, continuing on. F of x is equal to x plus 1. G of x is equal to x squared plus x plus 6. Determine the equation for f of g of x. Of g of x. Okay, so what am I doing? I'm taking g of x and I'm replacing it, this whole function, for x in the other function. So this would be x squared plus x minus 6. That's my x coordinate. Now for f of x plus 1. So this would simplify to x squared plus x minus 5. This is g of f of x. So now I'm replacing x, which is x plus 1, for every x coordinate or x value in g of x. So this would be x plus 1. I'd have to square all that. I'm replacing it with x, plus x plus 1. I replaced x with an x plus 1 again, and then minus 6. So we'd want to expand this through and then collect like terms. So I'd get an x squared plus 3x minus 4 would be my equation. f of x. Well, f of x means I'm going to, and I'm going to replace it with x in my other function. So f is x plus 1, but I'm taking the function f of x, which is x plus 1, and replacing it with x in the function. So it's an x plus 1. That's my x value, and then I got to add 1 to that. So it'd just be x plus 2. And then finally, g of x. So a little trickier here. So we'll maybe come down here because it's kind of long-winded. So g of x is x squared plus x minus 6. I'm going to replace this entire function every time I see an x in that function. Squared plus x minus 6. I need to square all that. Plus x. I'm going to replace that with g of x function again. And then I have a minus 6. So technically I have an x squared plus x minus 6. Really, I'm going to rewrite this as multiplied by itself. And I need to expand all of this through. So I get an x to the 4th plus x cubed minus 6x squared plus x cubed 6x minus 6x squared minus 6x plus 36. So that's this entire expansion plus x squared plus x. I'm going to collect these right now, minus 12. So now I'm going to collect all of my like terms. So my final equation would be x fourth plus 2x cubes minus 12 plus 2 would be minus 10x squared. So that's gone, that's gone. Minus 12x plus x is minus 11x. And 36 of would leave me with plus 24. So this would be my final equation. Okay. All right, and then the last couple things with composition of functions. Determine an original function from a composition of functions. So if h of x is f of g of x, determine a possible f of x and g of x. So when I look at this, it looks like the x minus 2 has been replaced with an x in this function. So g of x needs to be put into f of x. So g of x would be my x minus 2, and my f of x would be my x squared plus x plus 1. So this is more just like reasoning in order to answer this question. Similarly here, it looks like the x minus 1 has been replaced into this radical function. So it looks like my original function was simply this, and the x minus 1 was replaced with x. So that tells me g of x, which is what I'm putting into f, would be x minus 1, and f of x would be root x cubed. Okay, and then the last thing, it says if f at 3 equals 5, g 3 equals 3, or sorry, g at 2 equals 3, h of 5 equals 9, and k at 0 equals 2, determine h of f of g of k of 0. So what does this mean? It means I'm going to find h of f of g of k 0. So again, even though it's a challenge, it's actually a fairly straightforward question. I'm going to start and work from the inside out. I'm going to find the value of k of 0, which equates to 2. So now I'm going to replace k of 0 with 2. So now I'm going to h of f of g at 2. So now g at 2 equates to 3. So now I'm going to replace g of 2 with 3. So now I'm going to find h at f at 3. Well, now I'm going to find f at 3, which is 5. So now I'm going to replace f at 3 with a 5. And finally, h at 5, which gives me 9. So my answer would be 9. Okay, and so that is the end of composition of functions.